what the surroundings are telling me. So let me give you a couple of more examples, and these are real examples of stuff that's either already in flight or it's already done, and or some things that it's futuristic. So what's our philosophy? How do we operate? What's our philosophy at AIG? Science. And yesterday we had an interesting discussion on why is it science? What does science mean? So science to us, just the way I said that it's data, technology, and computer science. It's not data science alone. It's not big data alone. It's a combination of all of these. And then there are technologies and there are areas in computer science that it's still under research, and we continue to work on those areas, and I'll talk about that in a moment. So essentially, it's simple, right? I think this is very simple. That this is about conceptual thinking, and I think that's where the USP comes. That can I think of how can I leverage some of these, technology or data sets, or into which market and how that would play out. For example, if I were to do a car sensor investment in India, it would not work, right? So I would not even go down that path. But in India, there are so many other micro-insurance opportunities using data science that, that are much more feasible and then much more tangible, your crop management and so on. So things like that. So the first part, the bigger challenge is to find out, what is the problem area, what is the sweet spot that you want to get into, what is the problem that you want to solve. And then obviously get around, getting access to, or getting different data sets, getting different data sets around it, right? So what is the right data that you would need to get in order to get that? And that data could be internal, external. Sometimes you don't even know. The idea is just get all data. Just get all data, whatever you can get access to. And then we start building the models, or what we call the models. And then finally is that, we move into solution. A lot of times, sometimes people end up starting with a solution that, this is how I want to present, and then, work out how the other modalities would work out. But I think our approach is completely different. We go first, what is the concept? And then we say, okay, this is how we want to deliver it on a mobile app, or this is how we want to deliver it on a desktop app, or this is how, the drones would leverage some of these. And this picture tells you, exactly what I spoke about, and obviously I have oversimplified the whole business of insurance. That it's just about, but fundamentally it is about getting premiums and settling claims, right? But internally, and as some of you are, like I said, are industry experts in insurance, or have spent a lot of time, you would know that the insurance, if you break down, is so complex. It's because obviously, if it were just, just a give and take, it would have been a very different business. But insurance is so complex, right? Because there is fraud, and when you are settling claims, then you need to also filter out fraud. There are like any business, there is prospecting. How do you target your customers? Now think of it this way, right? Each one of us must be getting those telemarketer calls saying that you need this product and you need that product. So rather than getting targeting at the right customers, and I'll show you in a moment an example of how we are using science to do that. Then essentially, there's so many different, on our submission prioritizations, there's so many different claims or so many different policies to be written. And these because the industry is heavily regulated, these have to be underwritten by very, very qualified people only. And they have a huge queue of what policies do they bind and what policies do they write. So what should their workload be looking like? How can a computer tell them? So the idea is to say that how can computers do this for you, and then you use humans to just add the intuitive element to it. Yeah. So let's look at some more examples, right? It's a pretty simple graph, but more than the graph, I'd like you to look at the left, what it shows on the left side. So here is an example of how we developed some of the anti-fraud claims models. Like I said, that if AIG settles about $200 million of claims every day, and that's the amount we settle. If I tell you the number that gets filed every day, it's quite a staggering number. We need to know what is fraudulent and what is not, and a lot of times there are a lot of fraud claims being, and then there is data to back them up and so on. Now, so we did this with this project was done a couple of months back, where we took the claims data, and then we created a model in science to not just to augment that data with some of the internal structured data that was available, but not just only with that, there were adjusters notes. So somebody who's looking and reviewing it just writes a note on scribbles and saying that, this is what I feel about it. That's it. Makes sense, does not make sense, or simple phrases like that. Now obviously there is computer science technology that was available many years back to recognize handwritten notes, but the point in science was, how can we make it more contextual? How can we apply the context and then come up with a more and then also what has been the pattern for this? So there were other areas that were explored. Text mining, and then also using some external data points. External data points such as, what is the demographics that claims were originating from? Has there been a pattern around it? What is the location? And if you're familiar with how the claims process works and so on, you would know that certain areas are notorious, could have been, right? So we applied all of that historic information in that sort of fashion. And then we compared our results to what was some of the industry-leading anti-fraud, because fraud is existent. I mean, fraud analytics is, again, sometimes you would call it a commodity. If you're a credit card company, you are doing a fraud analytics. If you are an insurance company, so anywhere where you have to settle anything, you are doing fraud analytics there. So there are a lot of standardized techniques or standardized products, if you will, are available. And we compared and benchmarked our results with them. And and that's what it shows you, that our models were far ahead in terms of accuracy, in terms of predicting what is the probability of fraud than the industry leader or the market leader, if you will. And that's exactly what it comes down to, what I said in my opening statements, that it's all about managing risk. So for an insurance company, what is the risk of this claim being fraud? It's every step of the way, it's about managing risks. And sciences and leveraging more and more data sets and enriching data is helping us do that. This is an interesting project. This is, so okay, so let me talk about this. That each one of you, and I'm sure there are a lot of practitioners sitting in this room, we are a data science conference after all. A lot of times we are required to do, and whether you are in a retail or in a CPG environment or wherever else, right? When you have a prospecting, and that's what I was talking about, the prospecting piece. When you are prospecting, how do you know who's going to convert, who's not going to convert? What should I pitch? What should I not pitch? I wouldn't want to get bothered by multiple calls from AIG saying, do you want to buy this, or do you want to buy this, or can we get this to you? I would rather have a shutdown for a brand AIG saying, don't even bother me, right? That's how typically all of us behave. Again, expand this to not just a retail one-on-one scenario, expand this to a scenario where you're insuring a company or a country, for instance, or a shipping line, or we have people from Airbus, they would know that for aircrafts and so on. Right? How do I know what is the right thing to sell? And we create multiple models, right? So there are models for cross-selling, there are models from upselling, there are clustering, you do a whole lot of different things. You come up with multiple models. And in most large companies, and I'm telling you from experience, in most large companies, the left side sometimes do not talk to the the right hand. The left hand would not talk to the right hand. So, if I may have gone, if I'm from a certain X team, I may have gone and, pitched to you a certain product, and my colleague who has no idea, and yeah, that's why you have Salesforce and CRMs and all of that stuff. But what if we were to have one model that tells you, that actually marries and then applies algorithms and tells you in a much more accurate manner what is the probability of that customer converting or not, and then internally, also telling you what should you be pitching onto them, and that's what we have done. And that's what we have done using mathematics and using very deep computer science areas. So essentially that, right? So we've applied modeling techniques, we've applied mathematical methods to do that, and this is how we do. So again, those are the whether it's accident or health insurance or general liability, commercial property, etc. Those are the different products, and these are not the retail products where these are very sophisticated, commercial product lines. And then we marry that with, the client purchase history data and using some of these the deep learning algorithms that are created. So, whether we are creating, neural networks around it and using some CNN techniques and so on. So but the outcome is absolutely fabulous, that there is just one model for prospecting. There is just one model for prospecting, which tells you in a much, much more accurate manner, will the person convert, yes or no, and then at what product would it convert? Okay, let's also talk about the workers' compensation. So in India, obviously, the workers' market is not as sophisticated, but in a lot of the developed countries where AIG has a very strong presence, the workers' compensation accounts for one of the biggest set of claims. And also there are a lot of fraud around that, right? So if I'm a worker at say a construction site or a shipping site or wherever else, and if I file a claim with the insurer saying that, I was working at the site, I broke my hand, I'm out for the next 6 months, and I need compensation. How do you determine that? So, obviously there are standard ways and there are standard parameters. Was I, working at the right angle? Was I at the right height? Was I, sober? What food did I have? Was I stressed? And so on, right? But there are other parameters that we have, and some of those are proprietary, so I can't share all of that here. But interestingly, the whole approach was quite different. We realized that, first of all, that, 20% of the claims actually cost us about 57% of our cost. And so can we, again, here it was more about preventive. Can we start collecting data at an earlier stage and not at when the claim comes in? And so, early interventions changed our claim request dramatically. And at some stage, we are also trying to see, and obviously there are data privacy issues the world is yet to solve. But what if, I have filed for a claim, and at the same time in social media, I'm posting pictures, that I'm, out at a party, or, I'm happy with my friends and family and so on. So can we marry all of those external data and then come out with what is fraudulent and what is not, right? So those are, these are some of the insights, from very, very key business problems that, most of the firms have. So whether you're in insurance or not, but things like fraud, things like, optimization, things like better use, things like, getting ahead of the curve early, things like preemptive planning. Those are, I think, across, and that's where the entire paradigm is shifting to. Can we detect early? And use the non-traditional ways as well. Can we marry that with the traditional ways? Because the traditional ways are obviously, that's the root, that's the domain that the knowledge exists. But can we, again, apply the newer technologies, the advancements in computer science to some of this? And then there is research. Research is a very, very integral and core part of, what we do at science. So you heard my colleague yesterday talk about what we are doing on the NLP side, but there is so much advancements in computer science that can be harnessed, right? Right from, again, I repeat that, right from the device. I think it's fabulous because until I wore this device, I knew that I need to walk. I knew I need to be active during the day. Everything is known, right? It's not unknown to all of us, but till you see data, till you see that, oh my God, I've only done 5,000 steps. With my lifestyle, I'm only walking 3,000 steps in a day, that's it, that I just sit in my car, come to my office, leave my office, sit in the car and go home, and then I'm again, not moving around much. The moment data hits you, you start taking actions. And that's what, that's essentially what the core is. So here is what we do with respect to research, right? Because, if you go back, how do you develop that conceptual thinking that we were talking about? Because you need to be so, we work very closely, and obviously no firm, whether it's AIG or somewhere else, can actually have the collective brain power of all the research that's happening in various the top research institutes in the world. So we partner very closely with some of these top universities, and there are just a few of them, and then there are universities in the UK as well, with Oxford and others, where we sponsor some of their research and we get those people in, and we say, okay, and there are obviously, it's all green field, so we start and say that, okay, what are some of the areas? So things like computer vision, where you are, to me it's image processing plus 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 plus, or things like the Internet of Things. How can we leverage sensor technology, the drone technology? So AIG was the first one to adopt drone technology, where people cannot go and do field surveys if you're surveying a commercial property to say what's the level of damage, and if it's flooded or if it's fire gutted, and how do you go and survey it? Because you can't survey it accurately, you're making some guesses. Because you're making some guesses, again, your risks are going higher. So we are not, we've invested in drone technology to say, let drones go and take pictures. And then we'll apply computer vision so that a human doesn't have to see them, and can we train the computer to see those images and so on. Again, talking about preemptive, we are also working on what we call some of the transformative areas. Again, not just, sometimes it's beyond, profit and loss statements for a firm. Sometimes it's about, can we change the way people we live around. So AIG, the research team is at the core of what we call the road safety program, and it's partnered with New York University to say, and they have installed sensors at some very high risk crossings in New York City, and then getting sensor data and then saying that, what do we need to do at those junctions and so on. I wish, at some point, and I know Mr. Modi's vision is to have the smart cities, also connected cities and so on like that. But this is, these are transformative areas. I'm more than happy to answer questions, but to me, I think we are at a very, very fabulous stage where there is data available, and again, we were having some very interesting talk last night where everybody was saying that no longer is the case than people say, or companies say, or clients say that I don't have data. And now the conversation is about, I have data, tell us what to do with it. There is all kinds of data available. Tell us what to do with it. So there is data. There is fabulous technology that is available and continuously evolving. And obviously, the fundamentals of computer science have evolved to such a great extent that it is allowing for disruptions and completely change in mindset. So the whole point is about, yes, build from the foundation of all our traditional thinking, but let's embrace what the world is offering us in terms of, whether it's data, and don't discount any data. Let all the data in. Data is the new corporate asset. Thank you so much.
So it's time for questions. If any, you could raise your hand. We'll have a mic passed on.
Hi. Hi, Adu. I'm Dr. Rahul Vyas. It was a very exciting first session early in the morning.
Thank you.
A question is associated with the security of the data and the privacy of the people.
Sure.
So how you will tackle these two issues associated with the privacy of the people, because every sensor will capture your data.
Right.
And it will definitely affect the privacy of every individual who are aligned with AIG or maybe any insurance company.
Sure. So I think the data privacy and security, and I'm guessing you're talking about personal data, right? So if there's a sensor put in a wind farm and things like that, that obviously that's a corporate asset. But yeah, so there are global consortiums that are working as we speak to create data privacy laws. It'll be, and it's as good my guess as yours as to how that would pan out. And that's where I'm saying that, so that's a little bit of a gray area right now if you're trying to take personal data. But again, in the insurance space, none of us read all those policy documents and stuff that we get, the fine print there, but some of the data, when you actually sign up for that, you're okay to share. But yeah, obviously the concern is
when we take insurance, we never, read the terms and conditions.
Yeah.
Be honest with you, we just sign and we get it.
That's right.
Although everything is written there.
That's right.
But practically, if how to balance it, because privacy is also important. At the same time, risk dilution is also key for
Right.
corporates.
Right, absolutely. So there is no standard that is there yet.
Right now, there is no such like
Yes.